Okay, good afternoon. See you again for the second time in this week. Okay, thank you for joining the class. All right, last lesson, we move into this lesson three. Lesson three last week, isn't it? Last lesson, sorry. Lesson three is specific latent heat, right? Specific latent heat. Okay. Before I move into the topic deeper now, okay, I want you to tell me what is the meaning of latent heat. Latent heat is what? What do you understand about latent heat? What do you understand about latent heat? Latent heat is what? Jia Wei, young Jia Wei, are you there? What is latent heat now? Jia Wei.
Energy that change the state of a substance but no rise in temperature.
Yes, it's a heat energy required to change the state of the substance. Okay, change the state here means to change from solid to liquid or to change from liquid to gas. So to change from solid to liquid, you need heat energy, right? So this heat energy is called latent heat. Same thing when you want to change from liquid to gas, also you need heat energy, right? So it's called latent heat also. Okay, okay, now we will look at the paper now. Okay, let's look at the paper now. I hope you all have the paper lah. Go on click the wrong button. Okay. Let someone come in first. Okay. Okay, this was what we have done last week. Okay. Last week we have done this, right? Understanding specific latent heat, right? Also, we have studied all these heating curve and also cooling curve, right? Okay, so I'm going to start here tonight, okay, this part. Okay, look at here. This is what we are going to learn in detail tonight, okay? Definition and SI unit of specific latent heat. Okay, the first one you're going to learn now, please highlight this one. Specific latent heat of fusion, okay? Specific latent heat of fusion, okay? It's fusion now. Right, fusion means, okay, I put here already, is changing from solid to liquid, okay? The heat energy required to change from solid to liquid is called specific latent heat of fusion, okay? Fusion, remember now, fusion means change from liquid to, solid to liquid, okay? The symbol is L. For latent heat, the symbol is L, okay? Specific latent of fusion, the symbol is L. This is changing from solid to liquid. Okay. All right. Next. Look at here. The definition first. Okay. Highlight here. The definitions of latent heat, right? Okay. It's here. Is a quantity heat energy required to change. Okay. Also 1 kilogram, because specific, so we put it 1 kilogram. 1 kilogram of substance from solid state to liquid state. Okay, so remember that. Specific latent heat of fusion is a heat energy required to change 1 kilogram of substance from solid state to liquid. Okay, example is from ice to water lah. Okay, very important here, you must add here without a change in temperature. This latent heat of fusion does not involve change in temperature one, no change in temperature one. So it's only specifically for 1 kilogram. no 1 degree Celsius like specific heat capacity. Okay, this one no 1 degree one. It's only specific to 1 kilogram of substance. You want to change 1 kilogram of substance from solid to liquid. So that is called specific latent heat of fusion. Okay, another one, look at here, highlight this title. The specific latent heat of vaporization, also L. Simple is also L. So this is the second one. This is latent heat of vaporization. For vaporization, it's changing from liquid to gas. Liquid change to gas, so it's latent heat of vaporization. So remember, there are two, One is fusion, the other one is vaporization. Fusion is to change from solid to liquid, whereas vaporization is to change from liquid to gas. Okay, so remember the definition. Okay, now highlight the definition of latent heat of vaporization. Is the quantity heat energy required to change 1 kilogram, is also 1 kilogram of substance from liquid state to gaseous, change to gas. And then very important, without a change in temperature. Now you realize we don't care whether this is a latent heat of fusion or latent heat of vaporization. Right? At the end of the statement, you must add here without a change in temperature, meaning that changing from solid to liquid, during the times changing liquid, solid changing to liquid, right? The temperature remains the same one, Okay, that's why you say no change in temperature during that moment. Same thing when a liquid want to change to gas, right? Liquid want to change to gas. During that moment, the temperature also remains the same. No change in temperature, okay? And the SI unit for specific latent heat is joule per kilogram because only 1 kilogram. So it's joule per 1 kilogram. No per degree Celsius. I remember the unit different one, joule per kilogram only. Okay, formula. Highlight this formula. This is a formula involving latent heat. Okay, Q is a heat energy, Q equal to mL. Okay, Q is heat energy equal to mass multiply the latent heat, regardless is the fusion or vaporization, same formula, Q to mL. Okay, last week you learned this formula, right? You remember that? I put it here, Q. You learn this, right? Another formula, MC theta, right? This MC theta is involving specific heat capacity involving change in temperature theta. So remember these two formula, Q to mL. mL means fusion or vaporization is latent heat. Okay, MC theta is a formula involving specific heat capacity. Specific capacity means you see got change in the temperature one. When no change in temperature means latent heat Q go to mL You don't see change in temperature in this formula, only mL, but here got mc theta. The theta is a change in temperature. Okay, all right. Now look at example 1. Can you read the question? Read the question and then try to answer. Question number 1. What is the quantity of heat required to melt, and now to melt 2 kilograms of ice at 0 degree? Okay, it's given the latent heat of fusion of ice is this value, given the number. So very simple, very straightforward. You just see, use a formula, Q equal to mL, mass 2 kilo, latent heat value you take from here, 3.34 10 to the power of 5. So you get this answer. 6.68 times 10 to the power of joule. Okay, copy the answer now. So just use a formula, substitute, you calculate, you get the answer already. Okay. All right, example 2. This one a little bit more difficult. Okay. This one, let me explain the situation to you first. Okay. I put it here now to block it. Yeah. Sorry. Right. This question says something like this, How much energy has to be removed from 4 kilograms of water This water 4 kilogram, temperature is 20 degree, not the water. Okay. To produce a block of ice at 0 degree. Now got so many steps here, no. And then you are given specific heat capacity water, this value 4,200, and specific latent heat fusion ice is this value. Okay, you look at here. Water, there are two stages, One is the water 20 degree, cool down to still water, but 0 degree. At this part involve change in temperature. Okay, change in temperature, no change in the state. You see, water, still water, but change in temperature. This is MC theta. This one is specific heat capacity because only involve change in the temperature. The state still water to water, no change in the state, so not latent heat. So remember, MC theta is here. Another one is now the water cool down to 0 degree already, and now only slowly the water frozen to become ice. Okay, now change in state happen from water liquid now go to solid ice, but temperature remains the same, 0 degree. This cold water is 0 degree, and then the ice also 0 degree. Here, involve change in the state from solid to liquid, but from liquid to solid, but no change in temperature, so it's latent heat, ml. So total, you take mc theta plus ml, so it's here lah. Okay, can copy from here now. Total heat energy is mc theta, m is 4. C specific capacity water 4,200. Theta change in temperature is 20. 20 degree cool down to 0. So change 20 degree lah. Right? And the other one is ML. Mass is 4. Latent heat value 334000. Okay? This value lah. Then you total up, you get this answer. Okay? So make sure you understand this example. You will get this kind of example one, In your calculation, most of the time involve more than one stage one. Not limited to just one stage, 1, 2, 3, 4, sometimes can be 4, 5 stages. Okay? Okay, understand? Okay, now we look at another question. Another question, this one even more complicated. Now you see the diagram I show you. Here got how many stages? Calculate the heat required to convert 4 kilogram of ice at -15. -15, ice are solid into steam. Steam is gas already at 100 degree. Okay, so all these values are given for specific capacity of ice, specific capacity of water, latent heat fusion of ice, latent heat of vaporization, all given. If given means normally you have to use lah. Okay, so now you see, look at here. Okay, yeah, 1, 2, 3, 4 stages. You must understand the stages I put here now. Okay, go understand it. Started with ice, solid, -15 degree. And then the ice get heat up to 0 degree. From -15 go to 0 degree, but still ice, Here now, involve change in temperature, so it's MC theta, right? And then the other one is now ice 0 degree, it melt to change to water, but it's still 0. Remember, when the ice melt to water, the temperature remains the same one. So this is latent heat, ml. No change in temperature, but change in the state from solid ice to liquid water, so it's ml. And then the water from 0 degree, you heat up to 100 degree, but it's still water. Okay, so this one involves change in temperature, so it's MC theta. Okay, now the water we heat up to water at 100 degree, right? Then the last one only the water 100 degree only change to steam gas 100 degree. The temperature remain 100 degree. You see now, when water change to gas, right, or steam, right, the temperature remains the same one. So here is ml. No change in temperature. Okay, so you have 4. So you add up mc theta, ml, mc theta, ml all here 1, 2, 3, 4. So you add up. Okay. So you see here one by one now. Why I put the number like that? Okay. I hope you can understand now. You look at it now. Mass is 4. C specific capacity for ice is 2100. Theta 15 degree because from negative 15 change to 0 change 15 now. M is 4. L latent heat of ice. Okay. 3.34 10 power 5 this value. And then here MC theta for C specific capacity for water 4002. Change in theta is 100 degree here. Okay. Now it's from 0 to 100. So 100 degree now. And the last one is ML. L, this one is latent heat of water, okay? Latent heat vaporization of water, 2.26 10 to the power of 6. So this value. So use your calculator, calculate carefully, do carefully, then you get this answer. Hopefully my answer is correct. Please check, you all. Yeah, can you check the answer? I'm not sure this answer correct because I just roughly only. Okay. Okay. Right? So far, I can understand the calculation parts or not? Yeah. Yeah. Right. Okay. So far, okay, can understand, can follow the example. Commonly, can you follow? Common?
Yes, sir.
Can follow the few example. Caleb, can you follow Caleb? Caleb,
Yes, sir.
can Sima, okay, Sima, I see your name already here. Sima, how are you?
Okay. Fine, sir.
Fine. Welcome. Do you understand the example?
Yes.
Okay. Okay. Michelle, Chua, can understand? Michelle?
Yes, sir.
Can Juling, okay, understand?
Yes, sir.
Can Simpun King, can you understand? Sima, Simpun King. No sound, this Simpun King. Hong Chao Xian, can you understand?
Yes, sir.
Can and Chan Yuan Yi, can you understand? Chan Yuan Yi. Now also no sound. I want to find a student here. Let's see whether I never see his name. But he say he got follow the lesson, but I never see his name. Some of you never use your name one, so just I cannot see. Okay. Ken Leong can follow or not? Ken Leong?
Yes.
Can Oh Ho Wan Yin can follow?
Yes, sir.
Can okay. Today very loud already the voice. Okay. Darren, are you there? Darren To. Darren? Darren, are you playing handphone or? Darren, you playing handphone? Listen. Darren To. No sound. No sound means doing something else, I think. Okay. Kevin Lim. Okay, can follow?
Yes, sir. Can follow,
Okay,
sir.
good. Yes. Okay, come. Let's move on. Oh, yeah, sorry. Someone that they don't want to talk to chat only. Simpun King. Yes, okay, thank you. Simpun King. Chua Chan Yuan Yi. Okay. Yes, thank you, Chan. Darren To, sorry. You type here. Yes, okay. Darren, okay, thank you. Okay, now there's a lot of things you see to my. Okay, after this example, we see another one. The experiment now. So this one you must learn because starting this batch of Form 4, You all have a practical test, you know. Practical test means you have to carry out experiment on the spot one, you know. Okay, carry out experiment on the spot to answer the question. Okay, look at the title. Highlight the title. This title is to determine the latent heat of fusions of ice. We want to find out what is the latent heat of fusions of ice. Means we want to find, you want to melt, you want to change 1 kilogram of ice, right? From solid change to liquid. You need how much heat energy? That is the question. That is the meaning of finding latent heat of fusion of ice. Okay, but this experiment now we are not going to use exactly 1 kilogram of ice. You know, that will take long time. You know, when you want to wait 1 kilogram of ice to melt, right? Melt finish, you take a lot of time. So this experiment we not really take 1 kilogram of ice one. Okay, the amount of ice we use is up to us. Okay, because we are using formula to calculate. Okay. Okay, you see what you do, using a filter funnel, put a little bit of ice, then this is a heater. Okay, the method of putting heater like this is not correct, you know. You know what is the mistake here or not? Then this one connect to power supply. So you see the heater, heat up the ice melt, isn't it? So the ice change to water, so the water drip down. So collected in the beaker here, right? Okay, but we are not going to wait until this 1 kilogram of ice here all melt, you know. No, we don't do that, okay? Just now I mentioned, right, this diagram here got one mistake. Can anyone guess what is the mistake there? Can you tell me what is the mistake here? I say got one mistake here. What mistake? Juling, can you guess? Juling, one mistake,
Need to have the tissue to cover the filter funnel and the
Yes,
water.
that's one. You need tissue to cover is one. There's another more serious mistake, you know. What mistake is that? Tissue is one. You need, memang you need tissue to cover, of course. Okay. And one more serious mistake is what? Kian Leong, any idea? Huh?
Position of the heater.
The position of heater lah. Not put here lah. Then put where lah? Put inside the water. Here, you put here lah. The position I think is okay lah. Huh? Okay. Chao Xiang. Hong Chao Xiang It's something to do with the heater. Yes. Kian Leong said it half correct already. It's something to do with the heater lah. So what is the mistake with the heater?
Need to be immersed, is it?
Yes, correct. It needs to be fully covered by the ice. If you don't fully cover, means that the heat can loss. You know, you see heat run away from here. The heat loss already, So heat loss means that the heat not used to melt the ice. That's why your experiment is wrong already. So it's supposed to be used ice fully cover the heater. Must be fully covered. Understand? Fully cover the heater by using ice so that we can reduce the heat loss. Understand or not? Okay, now there is another set of experiment. When you look at the bottom there, we say control set. Why is control? Okay, why need to have another one is control experiment? This is something you need to learn. Okay, let me explain to you why we call it control. Okay, there are two, you know. When you look at this setting of experiment, right? Are you sure this ice is only melted by the heater? Are you 100% sure? The ice melted here, the water dripped out here, all because of the heater? Are you sure? Kelvin? Kelvin Lim, can you 100% sure the ice melted is because of the heat from the heater? Jerry Go? Are you 100% sure the ice melted by the heat from the heater only?
No.
Juling? Juling?
No.
No. Okay. If not, then the heat from where can melt the ice? If not 100% from the heater, the heat melt the ice. There is another source of heat that can melt the ice, from where? Kelvin,
Surrounding,
Conway?
sir.
Yes, very good answer. Correct. It's from the surrounding. That's why this is a problem now. When you do like this, we assume the heat from heater only melt the ice. That one is wrong, Actually, heat from the surrounding also can come. Surrounding heat also can melt the ice, isn't it? So meaning that this experiment totally fail one, not accurate. Because we are very stupid, we assume the heater only melt the ice, but we also know actually surrounding heat also can melt the ice. So this is a big problem, correct not? Okay, now to encounter this problem, we use a control experiment. Now you see the control experiment. The control experiment, everything are exactly the same except no power supply. You see or not? No power supply here. No power supply. Okay? No power supply, but the ice dripping down, the water dripping means the ice melt. Okay, the ice here is melted due to the heat from the surrounding, correct not? So meaning that this control experiment can reduce our problem because this control experiment can determine the mass of the ice melted by the heat from the surrounding, right? Whereas here this set is, you see the water here got more, isn't it? More water here. This water is this ice melted by the heat from the heater and also heat from the surrounding. So what you need to do is you take the mass of this water minus the mass of this water. So you get the exact mass of the ice melted by the heat from the heater. So you solve the problem already lah. Just take this mass minus this one. When you minus, you get exactly the mass of the ice melted by the heater only. Okay, so the heat melted by the surrounding heat problem can be solved by using control experiment. Hey, you must remember, in the experiment, exam question they ask you, why need a control experiment? Okay, you must know the reason. Okay, now come calculation. We do like this. So first, this speaker you don't put here first, okay? So you on the heater. The moment you on the heater, right? Then only you put the beaker inside. Okay? Understand now? The moment you on the power supply, you put the beaker and also you start the stopwatch. Okay? Stopwatch also must record the time. Normally we fix a time now. For example, like for 10 to 15 minutes. Okay? So that the most we do only 15 minutes long, so we set the time 15 minutes, then you see how much water here, right? Same thing goes to this one also, right? Okay, now the calculation part. Okay, the calculation here okay, electric power heater. Okay, the one you can just check on the heater, what is the power, for example, 80 watt. So you jot down, the power of the heater is 80 watt. The mass of each empty beaker, empty beaker also you must measure, beaker A, beaker B, the empty beaker, for example, 100 gram 0.1 kilogram, okay, for example. Then, when water start to drip from the filter funnel at the steady rate, the heater set A switch on, then you on the heater. You on the heater, then you on the stopwatch. The stopwatch is also started to record the time. And the empty beaker A, B placed beneath the filter funnel. Okay, you put the beaker inside to collect the water, right? Okay. After a period of time, let's say 15 minutes, I told you just now, we fix the time 15 minutes. We allow the ice to melt for 15 minutes, okay? Give a little bit longer time now, 15 minutes. Then after that, you measure the weight. The mass of both beakers so we measure mass of beaker A plus water 0.36, for example. Then the second beaker plus water is 0.15. Of course, this one more water inside, this one less right? Okay, now calculation. You want to find the exact mass of ice melted, right? So you take this value minus the empty beaker, 0.36 minus 0.1, 0.15 minus 0.1 minus the empty picker mass, right? Then you take the picker A reading, picker A minus the picker P1, the control experiment one is here. Then you get 0.21. This 0.21 is a final mass of the ice melted by heater only. Okay? You remember now, take this picker A minus picker B, so you get 0.21. 0.21 means here, you take the mass of this picker minus the mass of here, this one minus this, so you get 0.21, right? Okay? And now the calculation. Calculation is PT equal to ml. Initially was formula Q equal to ml, correct not? But Q, heat energy supplied by heater, so we put PT, power multiplied time, PT equal to ml. We are going to find the L, so bring the mass over to dy, so you get this formula. So you substitute power 80, time 15 minutes just now, change to second, right? Mass here must be the mass of ice melted by the heat from the heater only, okay? So it's 0.21. So you calculate, then you get this answer, right? 3.42 times 10 to the power of 5 joule per kilogram, okay? Right? Understand the experiment now? Okay? And same things this experiment also got one problem, The problem is our answer the answer we obtain here is always not equal, not same as a standard value one. Sure is bigger than a standard value. Okay. Okay. Now we look at here. What is the reason? So you see here. Okay, the answer. On the assumption that there's no heat loss of or this formula, like use this formula to calculate, already. Okay, precaution here. So please read precaution. The immersion heater must be fully immersed in the ice. This I told you just now, right? To avoid or to reduce the heat loss. And one more is the whole set of experiment need to cover by cloth. That also need to do because heat can run away, So you have to cover also Okay. And discussion. The value of specific latent heat of fusion for ice determined is larger than the standard value. Please highlight, always larger one. So meaning that next time when you do the experiment, you must expect your answer always bigger than the standard value one, must be bigger one. The reason is, highlight, this is because experimental values of mass of ice melted less than the expected mass due to heat loss to the surrounding ice. Because some of the ice are lost already. Some of the heat lost to the surrounding, right? So some of the heat from the heater run away, run to the surrounding. So this will cause less ice melted. The ice melted become less already. That's why we say the mass of ice melted less than the expected value due to some heat loss to the surrounding. Because heat from the heater lost already. That's why the mass of the ice melt become lesser than the expected value. Okay. Now by looking at this formula, when the mass becomes smaller, you divide by a smaller, so your smaller number, so your answer becomes big log. That's why it's always the same. This latent heat number, the result you get should be bigger one, because this value small. When you divide by a smaller number, you get a bigger answer. Okay, understand? So far, understand the experiment now? So far, okay or not? You all can understand or not? Salvation, can understand? Salvation?
Yes, sir.
Can follow, Okay, Yutong, can you follow? Yutong, can understand? Yutong,
Can, sir.
can follow. Hashini, can you follow?
Can, sir.
This little
Can,
cute
sir.
girl. This little cute girl here, huh? Hashini. Okay. Kailin Yao. Can follow Kailin? Kailin Yao can
And
follow or not? Can Siu Mei? For Siu Mei, can understand?
yes.
Very good. Okay, thank you. Can one you? Can you follow? Can one you? No sound. Can one you? Adrenaline? Adrenaline? What about you?
Yes.
Can follow or not?
Can.
Can Ching Han, what about you? Ching Han can follow? Ching Han, no sound. Cherish can follow?
Yes, sir.
Yes, sir. Okay, who is this? ZY. ZY. Who is ZY? May I know who is ZY? No sound also. ZY, no sound. Okay. Tan Choming, can understand? Tan Choming? Tan Choming, he will type one now. Sao Kang, can I understand? Sao Kang?
Yes, sure.
Can I? Okay, thank you. Okay, so far you all can follow lah, Okay. I think someone has asked question. I see whether got anyone ask question or not. Jing Han, thank you. Darren, thank you. Tan Choming, okay, thank you. Okay, you all got any question to ask or not? You all don't want to ask. You all don't want to talk. Never mind, you can type. Okay, I read now. You got any question to ask? And last night group, they asked a lot of questions through the chat. They ask question. Got anyone here? You got any questions? So you type there lah. I can read. Chan Yuan Yi, any question or not? Chan Yuan Yi. Chan Yuan Yi, any question? No lah. You don't want to ask any question one now. Okay, come. Let's move on. Okay, next one I going to very fast, Determine latent heat or vaporization of water. Just now was fusion of water. Now is vaporization of water. Okay, vaporization of water means you want to find out to change 1 kilogram of water to steam or to gas, right? You need how much energy? Okay, that is latent heat of vaporization. Okay, understand? This one more difficult, because to change 1 kilogram of water into steam is a bit difficult, take long time. But as I told you just now, we are not that stupid. We are going to use 1 kilogram of water, and then we wait 1 kilogram of water all change to steam. That one you take 1 day, 1 night. 1 day, 1 night only you finish your experiment. So you are very stupid if you do that, right? So we never do that one. Okay. We are using a calculation method, so we are not strictly follow, say, use 1 kilogram of water. So we want to wait 1 kilogram of water or change to gas, change to steam. Then only you get your result. No, we don't do that. Okay, now look at this experiment. So this is a beaker, right? Beaker, you put a little bit of water here. Okay, water. And the whole beaker put on a weighing scale, a level balance, Put on a level balance. This experiment is special one, You have to put on a level balance because you know why, Because while this water is changing to steam, right? The water getting lesser and lesser, right? So you can see here the mass, the reading of the meter here will drop one, It will drop. Yeah, it will getting lesser lah. because water evaporated already, the water changed to steam already, right? So the water less, you can see here, the water, the mass become less. So it's very straightforward now. You can see here, how much water disappeared already. You can just read from here. Okay, read from the level balance. Okay, as I told you just now, when you do the experiment, the heater must be fully submerged inside the water. Must be fully submerged. Okay, and also you need to cover for best result is always you cover it. Okay, you need to cover it. And also you need a thermometer here. Thermometer you put here, you know why, First, the experiment you start like this, you get record the reading of when you put water here already, right? And then you get the reading. Initial reading, you must get what is the mass of the water inside. Okay, you get the mass initial reading. Before you start, you get the reading of the mass. Okay, all right. After that, you start the power supply. Start power supply, right? Okay, so the water will slowly be heat up, but you don't start your stopwatch. Okay, the stopwatch is not start yet, until the water started to boil, because latent heat of vaporization means is a heat need to change water to gas to steam. So you must wait until 100 degrees. Okay, you must heat up. That's why you take long time you must heat up the water until 100 degrees. Actually, you need to have a thermometer to check whether it's 100 degrees or not. Or you don't have a thermometer, never mind. You can use your eyes to see. How to see that? How to see the water is boiling? After limb, how to see the water is boiling? After limb, if no thermometer, how to see? After? How to
Got
see?
bubbles.
Bubbles, or you see the vapor is coming out, evaporating, isn't it? You can see the vapor come out. When you see the vapor started to come out, it means you can start the stopwatch already. Okay, it's already 100 degrees. At that time, you start the stopwatch. Then you let this water continue to boil for maybe for another 15 minutes. Okay, so let's see how to do the experiment. Electrical power of heater record. Okay, you always check the heater, see how many watt, let's say 80 watt record. Then electric heater switch on to heat the water to its boiling point. I see. This one you just heat up the water until the boiling point 100 degrees. Okay, or you see water vapor come out, you see the bubble here, right? Then when the water start to boil, it is very important to highlight. When the water start to boil at a steady rate, then the stopwatch is started. Then only start taking time, start the stopwatch. Okay, start stopwatch, and the reading on the balance is recorded. At that time, you see what is the mass of the water here. Okay, let's say 500 grams. Okay, when you start your stopwatch, you get the reading. So it's, let's say 500 grams. Okay. Then, after a times the reading on the electronic balance of 15 minutes, okay, we let it boil for another 15 minutes, So you see the reading again, it will drop to 468 grams, for example. The water become less, right? Because the water evaporated already, less water. Decide the mass from 500 drop to 468 grams. You record it. Then calculation. Then our calculation is just use straightforward the formula PT equal to ml. You want to find the L, bring the M divide. Okay, power 80 watt from the power, the heater. Time, just now we said 15 minutes, right? Change to second. The mass 0.032. Where to get this 0.032? Where to get one? Can anyone think of it? Where to get 0.032? Where to get this mass? When you think of it, and tell me where to get this number 0.032 here. Cheris, Cheris, I saw your name here. Cheris, Do you know or not how to get this number 0.032 here? The mass of the water have changed to steam, which is 0.032. Cheris? Magnesia, can you tell me how to get this number 0.032? Finish? Sima, are you there?
Yes.
Sima?
500 gram minus 468.
Yes, very good, very smart fella. 500 gram minus 460 gram, you get 32 gram, right? So 32 gram was the water evaporated. The mass of the water has changed from liquid to steam, which is 32 gram, correct not? And then you change to kilogram. Divide 1,000, change to kilogram, you get 0.032. Understand? Those who don't know one, please take notes how to get this. Then you calculate, finally you get this answer. Okay? So this is the latent heat of vaporization of water 2.25 10 to the power 6 joule per kilogram. The unit is joule per 1 kilo, right? Even though we never use 1 kilogram of water, but our final answer you calculate already, the unit has to be in kilogram, okay? Joule per kilogram. Okay, Okay, same thing again. This answer, the answer you get from the experiment, right, must be always larger than the standard value. Must be bigger one. You roughly, you know what is the problem already. Why the answer we get always is bigger than the standard value? Okay, now, I think I don't need to explain. You already know, right? Some of you, because heat loss, isn't it? Okay, now you see here. Okay, this one no need to explain now. So look at here now. The precaution. Immersion heater must be fully immersed in the water. I told you already, right? Just now, make sure the immersion heater is fully covered by the water to reduce heat loss. And also you need to use a cloth to cover the whole beaker. Okay, discussion, same result here. Value of specific latent heat of vaporization determined is larger than the standard value. Always happen larger than the standard value. The reason is because experimental values of mass of water evaporated is less than the expected value, meaning that actually less water evaporated, because some of the heat loss, isn't it? So less water evaporated. So you say the mass of water evaporated less than the expected value due to some heat loss to the surrounding. If I use this formula, when the mass are smaller, you divide by a smaller number, your answer always bigger. Besides, this value is always bigger. Okay, same reason now. Okay? If the question asks you, what is your precaution you must take to improve the accuracy of experiments or how you answer? Class. This kind of question always asked one, in the SPM question. What precaution you must take to improve the accuracy of your answer? How you do? How you do it? How to make your answer more accurate? Okay, of course you must say, first, we must check, make sure the heater fully covered by water. That's one. Second, you must say the whole beaker must be fully covered by using cloth, isn't it? To prevent heat loss, right? The only thing you can do to improve the accuracy is you must prevent heat loss. That's it. Heat loss, you will cut down the heat loss. When you can cut down the heat loss means your answer will be more accurate. Okay, Okay, now this question. Okay, answer this question now. 800-watt electric heater use boil water. What is the time required to reduce the mass of the water by 4 kilograms after the water has reached the boiling point? You see, after the water already reached 100 degrees. So you need to entirely make the 4 kilograms of water all disappear. Okay, now PT go to ml. Power 800 watt. Time they ask to find. Definitely this time will be very, very long. Mass 4 kilo, latent heat, okay, latent heat vaporization, this number given one, then you calculate, you get this number. This is, the time is very long. Of course, it's long lah. You want to change 4 kilogram of water to steam to gas, memang you take very long time, right? 11,000, I think this is not too long so lah. Okay, actually when you change to hour lah, this is roughly how many hours? 11,300 seconds, roughly how many hours? You know, 1 hour is 3,600 seconds, correct not? So I think it's around 3 hours lah. 2 hours plus to 3 hours. This is a long time, no? Okay. Okay, example 5. 0.5 kilogram of solid heated by 100 watt heater. The graph shows how the temperature varies. You see, this is temperature change. This is the time in second. Okay. So you can notice here now, at first you heat up, so the solid, the temperature go up from 20 to 80 lor. So the temperature go up, the temperature go up. Then when reach 80 degrees, it started to melt. So meaning melting point is here, 80 degrees. Why here I say it's melting? Because the temperature stop changing. When the temperature stop changing means change of state happen. The latent heat fusion happen here. You remember or not? Latent, when involve latent heat means no change in temperature, correct not? So you see when the temperature stop changing means here involve latent heat. So here is heat capacity, mc theta. Here is ml. So here is mc theta, remember or not? Okay. Okay, now the question is calculate the latent heat of fusion, find the L lah. So use the same formula, PT equal to ml. You want to find L, so it's PT divided by mass. Power given 100 watt. T 750. Where to get 750 second here lah? Where to get this time? Where to get the time? Where to get the time? Yong Jia Wei, where to get this time 750? Yong Jia Wei, are you there? Yong Jia Wei, or disappear, or do you want to answer me? Okay, never mind. Okay. Sima, where to get 750 seconds?
1,050 seconds minus 300.
Yes. Yeah. 1,050 minus 300. Okay, so you get this answer, lor. So we only take the time for this part only, because only this part when no change in temperature involve latent heat. So remember, if you are given a graph to find latent heat, right, you must only choose the section of the graph that doesn't involve change in temperature. Remember that, These are tips, the trick is like that. Only use this part. So 750 seconds. And the mass 0.5. Where to get 0.5 is given in the question, right? 0.5 kilogram. Okay. So you calculate, you get this answer. Okay. 150,000 joule per kilogram. So this is the latent heat, right? Latent heat of fusion of this solid. Okay, so far can understand all? Okay. And then some application application, I think I want you to explain. Can you guys explain or not? In which area we using latent heat? And then this one is important for your essay question, You must know how to explain how the latent heat is being applied there, Okay, the first example, okay. I want someone to explain to me what is this, I think you're very shy, very scared to ask you all, no? Chai Pei Xin, are you there? Chai Pei Xin? Chai Pei Xin, Chai Pei Xin? No, not there. Or just keep quiet. Remain silent. Don't want to answer anything. Yes, sir. Chai Pei Xin. Okay, Chai Pei Xin, Okay, thank you, Chai Pisin. Okay, Chai Pisin, the first paragraph here, when can you explain what is the important point here, Chai Pisin? You read here, can you tell me what is important? What you have learned here? Chai Pisin, try, no, can or not? Okay, now my you're too shy to say anything. One now my come. Let me explain now. When we are engaged in exercise, strenuous activity means you do exercise lah. So we sweat. You sweat, isn't it? Sweating cool our body. Okay, you see, I'm sure when you do exercise, when you sweat, right? After you sweat, you feel your skin very cold one, you know. You know why? Why the sweat can make your skin, not your body temperature. No, your blood still remain 37.81, you know. You won't change the temperature. Only the skin. The skin will feel cold after you sweat. Okay, the reason is the sweat evaporate. Evaporate means you need to absorb heat, you know. For this sweat water to evaporate, you need to absorb heat, absorb heat, latent heat of vaporization, correct? Not absorb. Need to absorb heat, then only the sweat can evaporate, right? So the sweat evaporate and the body heat is removed as the latent heat of vaporization. That's why our body temperature decrease. This is wrong. This statement is wrong. No, actually our body temperature cannot be decreased. Remains the same one. Right? What we can say is our skin. Can say skin temperature decrease. The skin temperature, not the body temperature. No. Okay. Now your body temperature decrease means that you're going to die already. Okay. Right? So you all understand what happened here now. Actually it's a sweat. Okay. When the sweat evaporates, right, you must remember when the water, the sweat want to evaporate, you must absorb heat. Absorb latent heat of vaporization. Absorb heat, then we can evaporate. So you will absorb the heat from your skin. That's why your skin feel cold after you sweat. Understand? Okay. Second, drink can be cooled by adding several cubes of ice. Okay, you see this one, everybody do one. Okay, a cup of hot coffee, right? Hot chocolate, too hot, you don't like, you put ice inside, right? Okay, why by adding ice, you can cool down your hot drinks? What is the scientific inside? You might understand. No, normal people just say when you put ice inside the coffee cool down because the ice cold. This answer, SPM won't give you any marks. Not scientific answer. Understand? Okay, actually it's like this. You see what happened now? Drink can be cooled by adding several cubes of ice. The reason is, this is the reason, because when the ice melt, put the ice inside the hot coffee, the ice will melt. Okay, you see what is required when the ice wanted to melt? You need to absorb heat, isn't it? So when the ice melt, latent heat of fusion absorbed from the drink. Okay, so the ice will absorb the latent heat of fusion from the coffee in order for the ice to melt, right? That's why the temperature of the drink will drop because of this. You put ice inside the hot coffee. So what happens is the ice must melt, you know. When the ice melts, it will absorb the heat, absorb latent heat of fusion from the hot coffee. That's why the coffee cool down. Understand? Yeah? Do you understand?
Yes.
Why always
Yes.
wear a mask one? I see your picture wearing a mask. Why? Why must wear a mask one? Where you took this picture?
Family mart.
Or family mart. In the family mart, recently only you took the picture
No.
Oh, okay. Okay So you put a mask there so that nobody can see your face, Okay, good. Family marks, a lot of things to buy there, Okay, come, look at the third one. Food can be cooked by using steam. This one I think you know one. Normally we steam fish, steam chicken, right? Okay, but you must explain scientifically, how the steam can cook the fish and can cook the chicken, Okay, come, let me explain to you first. Look at this diagram. This is a wok, right? You want to steam fish, so you put a little bit of water here. Must put water, right? Then you must put a cover. You must cover it. You don't cover, you never cook one. You have to cover it, okay? Then you use a fire to heat up the water. Okay, what happens now? When the water evaporate, right? When you supply fire, supply heat, the water will evaporate, right? Okay, remember, when water changes from water to gas or steam, absorb heat, isn't it? Absorb heat, latent heat or vaporization. So this water will carry the latent heat or vaporization and then go up here. Go up and then got stuck here. It cannot go up because it's covered, isn't it? So the steam cannot run away because of the cover. So what happens is the steam condense. The steam will condense, experience condensation. So the hot vapor condense here, condensation, change to water droplets. Okay, now you see now. When this hot vapor wanted to condense back into water droplets, condensation, you remember or not? Condensation is absorb heat or release heat. Okay, you see here lah. Vaporization, the water boil to vapor, vaporization is absorb heat, is absorbed. But when reach here is condensation. So the hot steam now change to water droplets. So it's condensation. So condensation is release heat, remember lah. Here to here, absorb heat. But here change to water, condensation, release heat. Now the latent heat or vaporization is being released. Released, then it will come down. It will come down. The heat release come down to cook the fish lah. That is the reason the fish can cook very fast. It's because when the water vapor condensation it will release the heat, right? So the heat release eventually it will come down and then cook the fish. Some of the vapor not condense here, it will condense on the body of the fish, then even faster can cook. Because when the hot vapor condensation condense on the body of the fish, right, it will release the heat, release the latent heat or vaporization. So the heat release used to cook the fish or cook the chicken. Okay, now read here. Food such as cake, eggs, fish, buns receive large amount of energy when the latent heat, vaporization of steam release from condensing steam. So remember now, that's why I say you must cover it. When you cover it, you force the water vapor to condense. So only during condensation process, the heat energy will be released. Released, then come down to cook the fish. Understand? Yong Jia Wei, understand?
Yes.
Michelle Chua, understand?
Yes.
Can Ho Wan Yin, understand?
Yes, sir.
Very good. Now it's changed, I think very clear already the sound. Jin Yi Hong, understand? Jin Yi Hong. Jin Yi Hong Ong Zhao Xiang, understand? I see your face already. Ong Zhao Xiang, understand? Ong Zhao
Yes,
Xiang,
sir.
show your face lah, don't cover lah. Ong Zhao Xiang.
Yes, sir.
Okay, good. Show your face lah. Why you cover? Ong Zhao Xiang. Okay lah. So we have finished this lesson already. Now you can answer question. Okay, now you look at question 1. The answer D. Why? Why the answer is D? Latent heat is hidden or cannot see one, cannot be seen. Why? No lah. Hidden means the heat cannot be seen because no change in temperature. The reason, remember lesson early of the lesson we learned, right? Latent heat is also called hidden heat. Why hidden? Cannot be seen because you don't see change in temperature, so you don't see the heat. Okay. Yeah. Number 2, substance change from liquid. Liquid change to solid. Solidification. Liquid change to solid is solidification. All right. Number 3. Liquid naphthalene began to solidify, become solid. Which of the following is true? Heat release. So remember now, liquid, liquid now want to change to solid, right? So is release heat. The heat release is called latent heat of fusion. Okay, liquid, between liquid and solid is fusion. So the heat release is latent heat of fusion is released. Okay. And number 4. Latent heat is released during steam change to liquid. Kebalik the process lah, from steam change to liquid. This is release heat. Latent heat. Vaporization is released here. Okay, you see now, when liquid change to steam, this is absorb heat. Solid change to steam, sublimation, right, is also absorb heat. Okay. Then can understand all these people. Okay, got another 15 minutes. 10 o'clock, then I stop. Don't worry. I know you all feel very boring one every time follow like this. I only Mr. Tam only talk. You all listen, never talk. I want you to talk, but you all never talk. Why you all very shy? Very shy to talk. But during the tuition or in the school, right, you all very talkative in the class and talk a lot. Even during tuition also, talk a lot. One Ong Jiao Xiang, you talk a lot. One For Xiu Mei also talk one. Yong Jia Wei also talk. In the tuition talk a lot. Now very quiet. Joking on it. Don't get angry. You all. Okay, number 5. The graph show the cooling curve. This one cool down. Which of the following is true? The answer A is true because as Wx the temperature drop, right? The temperature drop is because of section Wx, the average kinetic energy decrease. Remember now, the average kinetic energy is a measure of the temperature. When the average kinetic energy decrease, so the temperature also will drop one. So remember that now. Why temperature drop? Because average kinetic energy of the molecule decrease. Why decrease? Because heat release. Once you release the heat, so the molecule got less energy already, less kinetic energy. So the temperature drop. Okay. All right. Number 6. Diagram show a process in which water change to steam. Water change to steam. So the heat absorbed during the process is called what? Okay, I call your name so you answer lah. Don't scared lah. Water change to steam. So the heat absorbed is called what? Let me guess who? Hashini. Hashini, can you answer? Hashini?
C.
Hashini. What answer? B.
Latent heat of vaporization.
Okay, let's see. Yes, correct. Latent heat of vaporization. Okay. Water change to steam. So it's latent heat of vaporization. Very good. Okay, Hashini. Yeah, number 7. Straight away see the answer already. When the hot steam condenses to water, we have just learned just now, right? Steam, I use the steam to cook the fish, right? So the hot steam condenses, right? So what happens is, when condensation means release heat, isn't it? Release heat. When release heat, But during the process of condensation, okay, class, when steam changes to water, during this changing periods, the temperature will remain the same one. Okay, remember or not? When involving latent heat, right, the temperature never changes, you know. When temperature never change means the answer is kinetic energy remain constant now. Okay, the kinetic energy remain constant, just like the temperature remain constant. Okay, when the hot steam condense water, during condensation periods, right, the temperature remains as 100 degree one remains. Okay, during condensation happen, during the boiling process, during melting process, all these process are involving few latent heat. So the temperature will remain constant. When temperature remain constant means kinetic energy remain constant. Okay, I told you just now, right? Average kinetic energy is a measure of temperature, right? Not. All right, number 8. Aniline melt at -6, boil at 184. This is the melting point. This is the boiling point. So at which temperature not be a liquid? Not be a liquid means not melt yet lah. So the answer -10 no? Lower than this ma. When lower than -6 means I haven't melted, it was still liquid. Sorry, still solid. Okay, so answer -10. All right, question 9. Why the answer is A? Why the answer A? Okay, you read, understand it. Why the answer is A? Table give the melting point and the boiling point of 4 elements. This is melting point. This is boiling point. Now the question, which element is a liquid at 1000? This a liquid means at 1000 degree is already melted. So the answer is here lor. Because melting point 660 1000 higher than this is already melt, isn't it? So it's already in liquid, but not yet boil because boiling point 2000 over 1000 means it's in between here lor. So it's in liquid form. Okay. Number 10, specific latent heat of fusion of ice. What answer? What is the answer for specific latent heat of fusion of ice? What answer? Let me call who? Kian Leong. Okay, Kian Leong. One answer, Kian Leong, number 10.
Donkey.
Donkey. Okay, let's see whether it's donkey or not. Yes, correct, donkey. Kian Leong, very good, thank you. So, latent heat fusion, the answer is to change 1 kilogram of ice solid to liquid water. Must have without change in temperature. Okay, the answer donkey, correct. Okay, question 11, calculation. Okay, you see yourself, you go to ML, calculate, you can answer B. Okay, I give you 30 seconds to understand, to copy. You go to ML, just substitute and then copy. And for those who done, can you answer question number 12? Question number 12. Then later you tell me what answer. Question 12. Okay, 20 seconds from now, question 12, you do yourself. Come, tell me the answer when you call your name. Okay. So question number 12, what answer? What answer lah? Who I cannot remember already. Chua Michelle. What answer? Number 12. Disappeared. Ho Wan Yin. What answer? Number 12. Oh, no answer. Zhao Xiang. What answer lah? Number 12. Hong Zhao Xiang.
B.
B. Yes, correct. Answer B. ML. Mass time latent heat. Okay. So you get B. Okay. Next. 13. You all try first. You all try. Let you try first. You all sketch a diagram like this. I see how many stages. You draw the diagram first. How many stages? Then only you calculate. Okay, can you do that? Follow what I did here. I don't let you see all. You go and draw the diagram. What state change to what state, and then what state, right? You draw the diagram first. What is the quantity of heat required to change 0.02 kilogram ice 0 to water at 40? Okay, can you draw the stages? What change to what? What change to what? Okay, try it out first. How many stages? How many stages involved in your diagram? Lau Quan Xuan, are you there? Lau Quan Xuan. Chan Yuan Yi, how many stages? Yi Mei Hui, how many stages are? Yi Mei Hui, no sao. Kian Leong,
Yes, two stage.
Two only, yes. Okay, let's see the answer, Yes, two only, two stages. Okay, two stages only here. Okay, now you can see now, ice change to water, temperature never change. No change in temperature, but change in the state. So this is ml. And then after that, when all the ice melted already, the water in degree goes 0 degree. Now you heat up to 40. This one change in temperature, so mc theta, ml plus mc theta. So you add up. So you add up, so you get the answer. This answer. Okay, copy down the answer. ml plus mc theta. So you get this answer 10040 joule. Yeah. Okay, we move on to 14. Question 14. 14 is here. Okay, this question 14 got many stages and all. You see that? No lah, 2 stages only. Okay, you'll see yourself lah, huh? 2 stages. The melt naphthalene 0.01 kilo, 90 degree. Okay, this one is already melted, is in liquid form, 90 degree. Cool until it has solidified at 80 degrees. So you have to cool it down to 80 degrees first. So here, change in temperature, but still liquid, no change in the state, so it's MC theta. Okay, when the naphthalene cool down to 80 degrees already, then it only start to become solid. 80 degree, liquid, now change to solid, but temperature remains the same. No change in temperature, so it's ml. So MC theta plus ml, you calculate now, so you get this answer. Okay, copy down the answer. What you may understand? Huh?
Yes.
Understand? Thai patient, understand? Thai patient, understand or not? She typed one, okay? So let me see what she typed. Yes, she said yes. Okay. Okay, next question. Next question, I think is very straightforward now. 2000 watt heater used to change 2 kilograms of water at 100 degrees to steam. It's already 100 degrees, so change to steam only, that's it. So PT go to ml, power 2000, 2000 watt, time you don't know. Mass 2 kilo. L, latent heat given 2.26 10 to the power 6. So you calculate, you get this answer, 2260 second. The time must be in second, okay? Yeah. So we move on to question number 16. 16 a little bit tricky there, okay? Come on, let me explain. Ready or not? Okay, number 16. A 500 watt electric heater used to heat 0.1 kilogram of liquid to its boiling point. So you heat up the liquid to boiling point, Then the liquid is allowed to boil for 3 minutes. So this 3 minutes is already boiling one, okay? So no change in temperature until the mass of liquid becomes 0.06, means become less already, Just now 0.1. After you boil it for 3 minutes, so it becomes 0.06. I mean, you minus 0.1 minus 0.06, you get 0.04. So 0.04 kilogram is already disappeared. Means the mass of the liquid evaporated is 0.04. The mass of the liquid, which is already changed from liquid to steam, is 0.04. So you put inside here. ET, time 3 minutes, change to second. So you get L 225,000 joule per kilogram. So the answer C. Okay. So here, remember, here must be the mass of the liquid. In this case, is evaporated. Okay, liquid change to, how to say liquid change to boiling point, and then boiling point, then it disappear, become less mass, so must become gas already, right? So change in the state, so must find the mass of the liquid evaporated. Okay, number 17. Why do people feel cold? They do not dry themselves after swimming. So we have discussed that because evaporation of the water, when the water skin stick on your skin, so the water evaporates, so it absorbs the heat from the skin, right? Water evaporates and causes cooling, okay? Why evaporate will cause cooling? The reason is when you evaporate, it will absorb heat of latent heat of vaporization from your skin, okay? All right, last question, number 18. A steam burn more damaging than boiling water at the same temperature. Why? Steam, when the steam burn are more dangerous than boiling water, you know. Boiling water when poured on your hand are not that dangerous compared to the steam, you know. Why? Why the steam burn is more dangerous? All right, so the answer, last question. The last question is, okay, it's here. The reason is steam burn more dangerous because the heat released from condensing steam. Okay, because during the steam burn, the steam you stick on your skin, right? So condensation happen. So during the condensation, it will release the heat now. Okay, latent heat of vaporization will release on your skin, so you feel very hot, very dangerous. Okay. Okay, one more question, number 19. Answer donkey. Why would wrapping a bottle in wet cloth be a better method of cooling than placing the bottle in a bucket of cold water? Actually, you want to keep cold, right? You cover the bottle with wet water. Wet cloth is better, you know. The reason is water from the wet cloth absorb the specific latent heat from the bottle to evaporate. Because the water will evaporate, so you need to absorb the heat, absorb latent heat of, okay, latent heat from the bottle, absorb the latent heat so that the bottle still cool, okay? Okay, everyone very quiet already. I think we stop here for today, okay? So, anyone, any question to ask here? Anything to ask? Carmen, anything to ask or not? Carmen? Carmen?
No, sir.
No, sir. No question. Nobody want to ask anything. You Tong, you got any question to ask? You Tong?
No, sir.
No, sir. Okay, Okay, if no question asked, so I will stop here tonight. Okay. So remember, be a good boy, good girl at home. Continue to study, every day. So spend about 2-3 hours, at least 2-3 hours to study every day, Okay, So all the homework your school teacher asks you to do, your tuition teacher asks you to do, whatever notes asks you to jot down, whatever paper asks you to jot down, okay, you must follow, okay? You must follow, study as usual in the school, and also like study as usual in the tuition class, understand? Okay? So don't waste time now, okay? This is not the time, you are not supposed to waste your time. Your Form 4 wasting time is very dangerous, you know. For next year, we will find it very hard for you to catch up, okay? Okay, So remember, take good care of yourself. Constantly study at home, at least set a time to study for yourself, okay? So thank you very much once again for follow this lesson until now, okay? Okay, thank you. Bye-bye. Bye-bye, everyone.
Thank you,
Thank
sir.
you, sir.
Yeah, bye-bye.
Thank you, sir.
Sir.
Bye, sir.
Bye-bye, bye-bye.
Yes, sir.
Yeah.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Bye-bye. Okay, bye-bye,